Hello viewers, in this video we will learn the visualization technique called the faceting. Faceting is data visualization technique that partitions the plot into a matrix of panels. Each panel shows a different subset of the data. The subset of data is generated by dividing the main data set by some discrete or categorical variable. By creating multiple panels out of main data, data analyst can rapidly compare the patterns in different parts of data and see whether they are same or different. So basic idea behind faceting is to show the entire data set into subplots, and these subplots are arranged nicely in a matrix format, rows and column wise, and each subplot shows different subset of data, and this subset is created using some categorical variable. So instead of explaining to you what the faceting is, let's jump into the R code and let's try to plot some facet charts. So we are going to load the two libraries here, the tidyverse library and gapminder library. We are going to use the gapminder dataset. So loading the libraries, gapminder dataset. So from this gapminder dataset, we are interested in looking at the GDP per capita trend over the past years, and we can do this with the help of line chart. So let's draw the line chart with the x-axis showing year and the y-axis showing GDP per capita values. Now this data, this gapminder data, has more than 100 countries. So plotting everything on one graph will be overwhelming. So what we are going to do here is that we are going to filter out only 5 countries as shown: India, Germany, Japan, United States and Australia. And we are going to plot the line chart for these 5 countries showing the trend of GDP per cap. So I'm extending this pipeline with ggplot function. The data layer is already been taken care by this filter function. So let's build the static layer. In the static layer, X will be the year and Y will be GDP per capita, GDP per capita, and color will be country, okay, and geom-line. Yeah, so that should give us the line chart for 5 different countries, the line chart of GDP per capita trend for 5 different countries. Fine. Now the problem here is that this line graph can be easily interpreted if we are only working with 5 countries. Now if we want to show more than 5 countries, for example, if we want to show 20 countries, GDP per capita trend for 20 countries, we want to show on a single line chart, showing all the 20 countries with different colors. Of course we can do that, but the chart will be too cluttered and there could be a lot of overlap, which we may result into losing out some important insight from the data. So that's one issue that we will have. Another choice we have is to plot separate line plots for each country using ggplot function. So we will get 20 different charts. That will going to serve our purpose, but the code will be repetitive and not memory efficient. So this option is also ruled out. We can think about the third option. The third option is to generate the facets. Now as we said earlier, Facets divides the chart into subplots that are nicely laid out in a matrix form. So this single line chart we can split up into 5 different plots, and each plot will give us the GDP per capita trend for that specific country. Okay, so let's do that now. Let's generate the faceted line chart. Now let me first copy this code, right? And I'm going to generate another layer here. Another layer will be a facet grid function. So this facet grid function will give me the faceted chart, but here inside this function I am going to use a categorical variable by which I am going to split and create the subplots for each country. Okay, so country followed by a symbol called tilde and full stop. So in the geom line, let me use the color equal to blue. Yeah, now let's execute this. Great. Now you can see that using the facet grid function, we could able to generate 5 different subplots. And each subplot is giving us the GDP per capita trend for that particular country. And we could able to generate the subplots using country as a categorical variable here. Please note that this symbol called tilde is used in front of categorical variable, and this tilde symbol is also followed with this full stop. This syntax is very important to generate the facets. Okay, great. Now you can see that the panels are arranged horizontally here. You can also arrange these panels vertically. So what you will have to do, so first let me copy this. Okay, now what you have to do if you want to generate the vertical panels is to switch the position of full stop and tilde here in the beginning of the variable. Okay, so full stop, then tilde, and then followed by categorical variable. So that should give us the vertically laid out panels. Now in the above charts, we have used only one categorical variable, country. Now what if we want to use another categorical variable, for example continent, and show the GDP per capita trend for different combinations of continents and countries? We can do that using facet grid function, and inside the facet grid function we will call out 2 categorical variables and separate them out with the tilde sign. So let's do that. Let me first copy this, and here we are going to use 2 categorical variables, continent tilde country. Now please note that the variable on the left of tilde, that is continent, is used to create the rows, and the variable on the right of tilde, country, is used to create the column. So you can see a separate row. Let me first execute this. So you can see a separate row for each continent and separate column for each country. Right, and our subplots are laid out in a matrix form. Great. Now one thing you may have noticed here is that the facet grid uses all the combination of 2 variables to generate the subplots. So you can see there are many empty facets. Yeah, and these empty facets are generated because the rows and column combinations don't have any values in the data set, and therefore they are not plotted. So for example, Germany, Australia and United States, they are not part of Asia continent, and therefore there is no data available, right? The second thing is that such kind of plots, grid plots, consume a lot of space. And if you want to show such kind of plots in your final report, then that may not be a good idea. One way of getting rid with empty facets is to use facet wrap function. So let's use the facet wrap function. So we copy this, and now we are going to use facet wrap function instead of facet grid. So what I have to do is simply use facet wrap instead of facet grid. Now let us execute this. Great. As you can see that this function lays out the graphs horizontally but wraps them into 2D. This is super useful if we want to arrange the plots in more space efficient manner. Okay. Now another important argument you can use within facet wrap or facet grid function is scaling. Now you can observe in this graph that the y-axis scales are same for all the plots. But if you look at the countries such as India, the GDP per capita is far smaller compared to the rest of the countries. So we may want to change its y-axis scale and zoom it a bit. So let's change the scale now. Now in order to change the scale, we will use scales argument here inside the facet wraps or facet grid function. In both the functions this is applicable, scales equal to, and because we want to change the scale for y-axis, we will use free underscore y value to the scales function. Okay, so let us execute this. Now you can notice that the y-axis scales for all the data panels is changed. Now if you want to change the x-axis scale, what you have to do is instead of free underscore y, you can use free underscore x values and assign it to the scales variable. Right. Now coming to the next point is you can get more control on the layout using the number of column and number of rows argument inside facet wrap function. So if I use these two arguments inside the facet wrap function, for example, let me use number of rows equal to 3 here. Okay, now this should give me the panels laid out into 3 rows. So if I execute, then you can see that the 3 rows have been created. So it basically gives you more control on the layout of the panels using number of columns or number of rows argument inside facet wrap. But remember that these two arguments, number of rows and number of column arguments, can only be used with facet wrap function and not with facet grid function. Okay, great. Coming to the end of the video, let's quickly summarize. Faceting generates the subplots, each showing a different subset of the data. There are two types of faceting, facet wrap and facet grid. Facet grid function produces two-dimensional grid of panels and uses all combination between two categorical variables to create a subplots. Thus, if the data for some combinations is not available, it leads to the empty subplots. Facet wrap, on the other hand, produces one-dimensional chart, but it wraps it into two dimensionals. Since it is essentially a one-dimensional chart, there are no empty subplots created using facet wrap function. If you want to change the scales of the facets, the x-axis or y-axis scales can be changed using scales argument. This scales argument can be used with both facet wrap as well as facet grid function. And finally, we can get more control on the facet layout using facet wrap function by passing number of column and number of row arguments. Remember, number of column and number of row arguments only work with facet wrap function. Great. Thanks for watching this video till end. You may also leave your comments or suggestions in the comments section. I will be very happy to read those and use them to make these videos more interesting. Also, don't forget to subscribe to my channel if you want to get the notifications of all the upcoming new videos. Thanks for watching. I will see you soon.